Alright, this is 9.6 Counting Principles Day 1. And this first example is you place 8 pieces of paper numbered 1 through 8 in a box. You draw one piece of paper at random from the box, record its number, then you replace it in a box. Then you draw a second piece of paper at random from the box and record its number. Finally, you add the two numbers. How many different ways can you obtain a sum of 12? So first thing that we're going to do is we're going to list the first number and the second number. Okay, so how many ways are there to obtain 12? So we could have 4 and 8. We could have 7 and 5. We could have 6. And then we could also have another 6 because remember we're replacing it. But then we could also have 5 and 7 and 8 and 4. So in total there are 5 ways. Okay, what about if we do without replacement? So without replacement, which one of these would not work? Yeah, this one right here, because if you already took out a 6, you don't have another 6 there. So you only have 4 ways. Okay, so for example number 1, we easily were able to kind of figure it out ourselves, but sometimes the numbers are too big or it's just impossible that we must rely on formulas or counting principles. So the counting principle states that if there are two events, m and n, the first event can occur m ways and the second event can occur n ways. The number of ways that the two can occur is m times n. And it might sound a little confusing, but once we do an example, that should help. So here's the first example. Alright, so we have example number 3. It says, how many different pairs of letters from the English alphabet are possible? So if we have a pair here, well, how many letters are in the alphabet? Yep, 26. And then they say nothing about not using one again, so we have 26 again for the second pair. And we're just going to go ahead and multiply those. We get 676. Okay, then the next one says how many 5-digit zip codes are possible when the first digit must be 9. So we have 1, 2, 3, 4, 5. Okay, so for our first digit, we only have one choice there. It has to be 9. Then for our second digit, we have 0 through 9, which is actually 10 digits. And then same thing for the other ones. So if we multiply all these out, we get 10,000 ways. 10,000 ways, yeah. Okay, so next we have a definition of permutation. So a permutation of n different elements is an ordering of the elements such that one element is first, one element is second, and one element is third, and so on. In other words, this is when order matters, right? Alright, so let's go ahead and start off with the example. So how many permutations of the letters A, B, and C, D, E, and F are possible? So I like to go ahead and do a chart. So we have 6, right? 6 different letters. So we have 6 letters there. And you're ordering these, right? So how many choices do I have for the first one? I have 6. Then for the second one, because I've already chosen 1, I have 5. Then I have 4, then 3, 2, and 1. So I could multiply these out. and I would get 720 ways. Alright, so if we want to generalize example number 5, in other words, there are n factorial ways of ordering n elements.